Thank you very much. And first of all, thanks for organizer for having me in this nice conference. My name is Chen. I'm from the AHIA Taiwan, where I work with a bunch of very talented students and young scholars. Today I will talk about how the POP3 supernova affect the first galaxies. So based on this nice review by Walker Brown and Naoki Yoshida, and also nice review talk by Raphael, we have some idea about how this first star form. So the idea is about I redshift probably 20 to 30 is a mini halo star to form, forge the primordial gas, and then forming the first star through the H2 cooling. And this star forming have a radiation, and eventually some then blow up a supernova. Then those dark matter and the baryon, there's a radiation remnant H2 region, eventually form into a larger halos, and probably forging this POP2 and also the POP3 star. But this is unknown. This is what we understand about this first galaxy in total theoretical point of view. So to examine the connection from the POP3 star to the first galaxy, I try to examine the effect about this, how the initial mass function of the POP3 star affect the first galaxies. So there are two different kinds of choice. I try to do one is using the initial mass function for the saltpeter-like IMF, but it's peak at the 10 solar mass. The other one is using the Uranus IMF. And because the different from the IMF, they will result in the different mass star and the supernova types. For the INF, top heavy one will have some more of this so-called apparent stability supernova called giant explosion. So the idea is try to examine this supernova explosion and remnant inside atomic cooling halo and how they mix with a pristine gas to form these first galaxies. So this is actually the initial mass function for POP2 star from my simulations, and we did this a single star formation. This and surprising see some very interesting features is this IF from this different setup with the first galaxy simulation show the slopes of this the IF actually is a power law slope, and this power law actually very sensitive to the INF, the POP3 star, due to among the metal cooling and the mixing. So this metallicity from these POP2 stars, actually you can see actually the metallicity roughly above 10 to minus solar in these systems, and the sun distribution and the sort of the redistribution of the metallicity depends on the exact how the mixing and also some POP 3.2 star formation. So this is a synthetic image from this simulation. I'm showing also this first galaxy from this simulation also shows some of the compact and also the clumpy structures when we do this, get the result. So the takeaway point is here is the POP2 star in the first galaxy actually associate with the choice of the POP3 IM, which means POP3 IM is very important in determining the property of the first galaxies. And they also observe some of the POP 3.2 stars, and they can be very massive, probably become the supermassive black hole seeds inside these first galaxies. And the metallicity roughly exceeding 10 to minus 3 solar, and this first gas is showing as 10 to 4 to 10 to 6 solar metallicity. And then we got a new simulation study with Song Yang just during this workshop. So want to using more sophisticated simulation to further to push the simulation of this first gases simulation. Thank you very much.
Thank you, Ken.